Now we're beginning our Chapter 8, Class 2, Solving Polynomials. So when we mean solving, we mean we take our polynomial, whatever the polynomial is, and we set it equal to 0. Alright? Now our zero product property says that if we have the product of two things being multiplied, the first one can equal 0, and if a equals 0 here, a 0 times b equals 0. So that solves our equation. Or the second one could equal 0. So a times 0 equals 0. So this one or this one, there's two solutions now because we have two things being multiplied. Now we're going to end up with an x squared here, or an m times an m would be an m squared. That means there's going to be two solutions. Anytime we have an x squared, there's the potential for two solutions, not just one. So that means that this could be 0. So if x equals 0, 0 times 0 minus 8 is 0 times negative 8 equals 0. So this is one of our solutions. And then the other solution, we're just going to simply take this and set it equal to 0. Because all I know, if x minus 8 equals 0, then 0 times whatever this has to be will still give me 0. So I solve that. That gives me x equals 8. So x equals 8 and x equals 0 are my two solutions, right? And if you want to check your solution, 8 times 8 minus 8 is 8 times 0 equals 0. That works. All right, let's try the second one. We said that all we need is one of our pieces to equal 0. So I set this equal to 0. 4m plus 8 equals 0. Because if this part equals 0, then 0 times anything will equal 0. So I solve it, subtract 8, at 4m equals negative 8, divide by 4, and m equals negative 2. There's one of my solutions. Alright, now I want to find my second solution, m minus 3. I just need that to equal 0. So if this equals 0, I'm good. So add 3, or you can probably do this in your head. Just look, if you plug in a 3, 3 minus 3 is 0. But we solve and get m equals 3. Those are my two solutions. Alright, so just to give you a little bit more, let's see what this looks like. Imagine I take y equals. So imagine I plug this function into my calculator and I say y equals 4x plus 8, x minus 3. It gives me this graph. It's called a parabola. Alright, and we'll be coming into dealing with this a lot in a month or two. So I want to change my window. So I hit the window button, it brings me here, and I want to see more of the graph. So I'm going to go to negative 25. And when I do that, that changes what I can see in my picture here. Right? But look at where the graph hits the x-axis. M equals negative 2. Well, negative 2 is one of the zeros of our function. M equals 3. 3 is the other root of our function, or the other 0. Alright, so that's why this technique is useful. Alright, so I want you guys now to try this one. Pause the video, give this one a try, and we'll check it tomorrow morning. Alright, we got a couple more things to do after this. So, what if it's not factored already? Well, you're just going to use your stuff from class 1. Alright, so the stuff we just learned last class was how to factor this. This is hard to solve this equation, but if I factor a p out, or undistribute a 5p, which I can divide out of both of these, that gives me a 1 minus 3p, right? 5p divided by 5p is 1. Negative 15p squared divided by 5p is 3p. Now, I just need each of these to be 0. If this equals 0, that gives me 5p equals 0, which is p equals 0. And then, if I want this to equal 0, then I set 1 minus 3p equals 0, and then I just solve as I would a normal little equation. And oh goodness, we have a fraction. But you know what? Fractions are people too, so that's okay. There's our two solutions. Alright, so try this one. Remember, you're going to have to factor it first, then find the two roots. Okay, so what if this one doesn't even have a 0? All right, it's not set equal to 0. So what you need to do is isolate or get everything on one side first. So add or subtract everything over to one side. So we want just everything to be to the left. All right, you're going to do the same thing here. Get everything to the left, then factor. So I got to add the 3a, and 12a squared plus 3a is 12a squared plus 3a, right? These aren't like terms, so don't go adding them. Now I can factor this. What can I divide out of both of those? All right, think. What divides out of a 12a squared and a 3a? Well, a 3 divides out, so I can undistribute a 3. And they both have at least an a, so I can undistribute an a. So that leaves me with 4a plus 1. So now I have my two things that I want to set to 0, right? Because if this equals 0, then 3a times 0 equals 0. So I'm going to do 4a plus 1 equals 0. And then subtract 1, get 4a equals negative 1. So a equals negative 1/4. And then what if this equals 0? That's 3a equals 0, so a equals 0. Those are the two solutions to that problem. All right, now we got one more slide, but you should pause and give this problem a try. All right, so here, an application problem. All right, I know you guys don't like the word problems necessarily, but this is where it actually matters. This is where it actually shows us interesting stuff. Okay, so here we go. A rocket is launched straight up into the air with an initial velocity of 125 feet per second. The height of the rocket above sea level is modeled by the formula h of t, which is just our function notation, h of t equals 125t minus t squared. So this is actually the correct equation for our scenario, where t is time in seconds. So t is our time, h is our height, or h of t. So really this is just the same as y equals 125t minus t squared. All right, so what is the height of the rocket when it returns to the ground? Well, obviously if it's on the ground, then our height is 0. All right, so let's look at this. We graph our function. So here's my equation, same equation here. I plug it into the calculator, and I tell it to graph, and I've already set my window to have it. So rocket's launched, goes up, and then as it arcs, time is on this axis, and height is on this axis. So we'll put that back over here. So that's how we get our picture. Now, we're setting it equal to 0. So we want to find when it's on the ground. So it's on the ground here, and it's on the ground here, right? And this is our time axis, and this is our height axis, h of t and t. All right, so it's on the ground at 2 points, at the very beginning, when it launches, and sometime later. So if we want to find how many seconds it will take, we really want to know where the t, or the x-axis, what we can plug in to make the height equal 0. So really what that's saying is we want our height, h of t, to equal 0. So we want 125t minus 16t squared to equal 0. Now this is just like the problems we were solving. All right, so what can I divide out of both of these? Well, I can divide looks like just a t. So I'm going to divide that t out, or undistribute it. It leaves me with a 125 minus 16t equals 0. Sorry about that. So then that gives it. All right, and to solve this, we'd like first part equals 0, t equals 0 is already solved. That's when we were launching it. That's when its height was 0 at 0 seconds. And then we also have this equals 0. So 125 minus 16t equals 0. Add 16t to both sides. And that gives us 125 equals 16t. Divide by 16. And that gives us 125 divided by 16 is 7.8125. 7.8125 equals t is our other solution. So now what I want you to do is you can try this problem. Very similar, all right? And all you really need to do is just factor it and find the two solutions. So it'll take this long for the rocket to hit the ground. And if we look at the graph, you can see here that's 8. It's a little bit less than 8, so that's our 7.8125 right there. So 7.8125 is the time it takes for it to hit the ground. All right, good luck. See you tomorrow.